What if I told you that one of the most underrated subjects in engineering is basically the science of making the impossible stay still? That's engineering statics. And yes, it sounds like the kind of class where things just don't move. But that's exactly why it's so powerful. Because before anything can safely move, it has to be able to stand still. Statics is the study of forces in balance. It's what lets bridges hold trucks, cranes lift steel, shelves stay on walls, and buildings survive wind, weight, and time. So today, here are 5 powerful reasons engineering statics is way more interesting than you think. The first reason statics is fascinating is simple. It explains stability. Every object around you is being pulled, pushed, compressed, stretched, or twisted. Statics helps answer the question, why doesn't this thing collapse? Take a bridge, for example. The weight of the bridge itself, plus cars, wind, and people, all create forces that must be balanced by supports and internal stresses. If those forces are not understood correctly, the structure fails. Statics gives engineers the language to predict that before anything is built. The second reason is that statics makes invisible forces measurable. You can't see tension in a cable or shear inside a beam, but statics lets you calculate them. That matters because a structure can look perfectly fine on the outside while being dangerously overloaded on the inside. For example, if you hang a shelf, the screws are not just holding it up. They're experiencing a precise combination of load, tension, and torque. Statics tells you whether 2 small screws are enough, or whether the shelf will rip out of the wall the first time someone puts books on it. Third, statics is not just theory. It's the starting point for design. Before engineers can study motion, vibration, fatigue, or failure over time, they first need to know what forces exist in the static case. That's why statics is used in civil, mechanical, aerospace, and even biomedical engineering. If you're designing a robot arm, for instance, statics helps determine how strong each joint must be. If you're designing a prosthetic limb, it helps ensure the device can support body weight safely and comfortably. In other words, statics is the part that tells you whether your design is possible in the real world. The fourth reason statics is interesting is that it trains a very specific kind of problem solving. You learn to break a complicated system into smaller pieces, draw free body diagrams, isolate forces, and balance equations. That process is basically engineering thinking in its purest form. And once you learn it, you start seeing the world differently. A bicycle rack, a crane, a ladder against a wall, even a person standing on one foot. All of it becomes a force system you can analyze. That shift in perspective is surprisingly powerful. Finally, statics is useful because it shows up everywhere in real life. Construction crews use it. Product designers use it. Manufacturing uses it. Even sports equipment design depends on it. Want a concrete example? Think about a trampoline frame. The tension in the springs, the load from the person jumping, and the support forces at the legs all have to be balanced. Statics helps engineers decide where to reinforce the frame so it won't bend or fail. So no, statics isn't just a pile of equations about things sitting still. It's the science of stability, safety, and smart design. It's what lets engineers understand how the world holds itself together. And once you realize that, statics stops feeling boring. It starts feeling like the hidden force behind almost everything built around you. 5 powerful reasons engineering statics is more interesting than you think is just one small part of statics. If you're interested, our full free statics course is linked in the description.